All right, whether you're a seasoned IT pro or you've just ever wondered how your computer actually works, you are in the right place. We're going to jump right in and take a hands-on journey through the entire life of an operating system. We'll be looking at Windows, macOS, and Linux, but from the perspective of the person who has to manage these systems, or endpoints, as we call them in the business, every single day. Okay, let's get into it. So, here's our roadmap. We're going to follow the complete life cycle of a computer, starting with its birth, the installation. Then we'll get it all set up, configuring and customizing it so it runs just right. After that, we'll put on our detective hats and play system doctor, figuring out how to diagnose and fix things when they go wrong. Then we'll unlock some serious power with the command line. And to wrap it all up, we're going to solve the permissions puzzle that drives so many of us crazy. Every computer starts as just a box of parts, basically bare metal. It's our job to breathe life into it by installing its brain, the operating system. And you really got to get this first step right, because it sets the stage for everything that machine will ever do. Right out of the gate, you have a huge decision to make: a clean install or an in-place upgrade. A clean install is like building a brand new house. It's perfect, it's fresh, there are no hidden problems, but you're starting from scratch. An in-place upgrade is more like a renovation. It's way faster, you get to keep all your stuff, but you might just be painting over some old cracks in the foundation. The right call really just depends on the situation. So, what's this process actually look like? Well, first, you've got to create a bootable USB stick, usually using an official ISO file. Next, you have to get into the computer's guts, the BIOS or UEFI, to tell it, hey, don't start from the hard drive, start from this USB drive I just plugged in. And finally, you get to be the architect of the storage, partitioning the drive and formatting it to create a perfectly clean home for the new OS. Okay, the OS is installed, the machine is alive, but our work is definitely not done. Now comes the configuration stage. This is where we tweak all the settings to make the system secure, efficient, and, actually usable for the person who needs to get their job done on it. In the Windows world, you're going to spend your time in three main spots. You've got the classic control panel, which is your go-to for really deep, nitty-gritty settings. Then there's the modern settings app, which is much more streamlined for everyday things like updates and privacy. And then, for the real pros, there's the Microsoft Management Console, or MMC. Think of this as your custom-built power toolkit. Now, the MMC is pretty unique. It isn't really a single tool. It's more like an empty toolbox. It's a framework that lets you build your own custom control panel. You add these powerful utilities called snap-ins, like Event Viewer to check logs, or Device Manager to look at hardware, and you build a personalized dashboard with just the advanced tools you need, all in one place. And this brings up a really crucial point if you work on different systems. The names of the tools change, but the job they do is pretty much universal. You use Task Manager in Windows or Activity Monitor on a Mac for the same reason, to see what's hogging all the memory. Once you understand the core idea of system management, you can jump between platforms pretty easily. Of course, even the most perfectly set up machine is going to have problems. It's just a fact of life. And that's where troubleshooting comes in. I think of it less like being a hero and more like being a detective. You're gathering clues, looking at the evidence, and figuring out what went wrong so you can make it right. Come on, we've all gotten this call. A user tells you, my computer is just so slow. And it keeps crashing. It's one of the most common and vaguest problems out there. There could be 100 different causes. So with all those possibilities, where do you even begin? The key to not losing your mind is knowing which tool to grab for which problem. If the computer's sluggish, your first move is always Task Manager. See what's eating up the CPU and RAM. If a specific app keeps crashing, the Event Viewer is your best friend. Its error logs will tell you exactly what happened. And if the whole system's unstable, the System File Checker is an absolute lifesaver for fixing corrupted OS files. Look, the graphical interface is great for most things, but the command line, that's where the real power is hidden. It's faster, it's way more efficient for certain tasks, and it lets you automate things with incredible precision. Honestly, mastering the command line is what separates a casual user from a true administrator. Consider this your command line cheat sheet, and you'll notice a pattern here. A lot of commands are just different dialects of the same language. ipconfig on Windows and ipaddr on Linux both get you network info. Ping is ping everywhere. It's the universal tool for, can you hear me now? And learning sudo on Linux or Mac is essential for running commands as an admin. Getting these down will make you so much faster. All right, let's pull all these ideas together and tackle a real-world problem. This is a scenario that every single IT pro has bashed their head against at some point, probably on a weekly basis: file permissions. This is where a really deep understanding of the OS pays off big time. So here's the classic ticket. A user from the accounting team can't save their work to the shared reports folder. You check, and they're definitely in the right security group. They should have access. So what is going on? Well, the answer is hidden in a really subtle but super important detail about how Windows handles security. The key to this whole puzzle is understanding that for shared folders, Windows is playing a two-level game. There are share permissions, which control access over the network, and then there are NTFS permissions, which control access to the files on the disk itself. In our case, the share permissions are wide open, but the NTFS permissions are locked down to read only. And here is the golden rule you can never, ever forget. The most restrictive permission always wins. So the solution is to make sure both layers of permissions are working together, not against each other. By setting both the share permission and the NTFS permission to modify for the accounting group, we create an effective permission that actually lets them do their job. It's a simple fix, but only if you know to look for that conflict between the two permission types. So what's the big takeaway from all this? It's that supporting an operating system isn't just a random list of tasks. It's a cycle. It's a repeatable framework. You install, you configure, and you troubleshoot. If you can master that lifecycle, you can confidently support pretty much any device on any OS that gets thrown your way. You know, the specific tools and commands we use today, they're going to change. New ones will come along, old ones will fade away. But the fundamental ideas, how operating systems are born, how they're configured, and how they break, those principles are here to stay. So the real skill isn't just memorizing today's tools, but understanding the why behind them so you're ready to adapt to whatever comes next. Thanks so much for joining me.